Good afternoon. My name is Rab Scott. I'm Head of Digital at the Advanced Manufacturing Research Centre, part of the University of Sheffield, and I'm going to introduce you to the 5G Factory of the Future programme that we are running from the AMRC. The 5G Factory of the Future programme. Partners include BAE Systems, IBM, AQL, who are UK-based mobile network operator, the Digital Catapult, MTT, or Machine Tool Technologies, and Miralis. The programme is funded by DCMS and is supported by UK 5G testbeds and trials. So what is the industrial imperative? Well, as we're all very aware, the UK productivity is lower than leading European nations, in some cases by up to 20%. And yet, to ensure that the UK companies can actually remain globally competitive, we've got to embrace the digital technologies, the transformational activities, and one of these is about data. And 5G is one of the latest technologies that really allow us to move data at rates and with precision and confidence that we haven't previously been able to. So the whole impact of 5G, of the digital transformation we're all going through, has got the opportunity and the potential to really reduce lead times, improve quality, improve productivity, and allow the UK to enhance its competitiveness on the national and international stage. And so we really got to allow people to understand what the benefits and opportunities 5G can offer are. And that is what the 5G Factory of the Future programme is all about. There are 5 main components. Industrial 5G connectivity is obviously the main one, but there's no point in having connectivity unless you can also demonstrate its application in specific use cases. So we've got a number of use cases, very similar to other programs, but as impactful for us as it is for them. We need an orchestration platform underlying all the data that's flowing. And there's no point in having access to data if you do nothing with it. You know, data is sometimes referred to as the new oil, but like oil, if it's crude, it's a cost to transport, to store, and you've really got to refine it. So we've got an AI compute platform that sits underneath the orchestration and the data. And besides all that, we've got an innovation ecosystem. We need companies to adopt 5G, but we need companies to innovate with 5G as well. So really part of the programme is building out up in the northwest of England, which is where the programme is really centred on, building out that innovation ecosystem about people that want to use 5G, people that want to manufacture for 5G and with 5G. And that's what the programme components are. The background, we need to understand next generation connectivity for manufacturing. We've really got to link up the shop floor to the top floor, the OT to the IT, operational technologies to the information technologies, because only by linking OT and IT can we really extract the greatest value that this opportunity could give us. We've got to extend it out into the supply chain. A siloed implementation of this just wouldn't give the demonstration of the potential value that is needed. Bringing together multiple stakeholders, collaborating across the whole of the Northwest Aerospace Enterprise Zone. But at the same time, it can't just be a vanity project. We've got to show the benefits for regional businesses and open it up as a sandbox environment for trials. And while doing that, the AMRC aims to develop itself as a centre of excellence around the use of data in manufacturing, and really look at the investments today can release that productivity tomorrow and drive future investment in this sort of technology. So, what are the use cases? Well, there are 5 of them. Our first one is real-time monitoring and adaptive closed-loop control. Until recently, real-time monitoring closed-loop control has been an aspiration rather than a tangible output. The ability to control systems, whether they're robotic systems or machining systems, integrated systems where different parts of the operation are interacting with each other without human intervention, is an aspiration. But with 5G, we believe that it can become a reality. And the challenge in doing this is actually to reduce cost and time associated with defects and quality, because if we can improve real-time adaptive closed-loop control in process, then we can reduce the amount of waste. Whether it is waste that comes at the end of a line and requires rework, that is a cost. You've got the material requirements, you've got the human resource requirements, you've got the lack of productivity because you've had to take equipment out of the primary manufacturing loop and put it into the rework loop. So if we can actually control the systems better and our first time yield goes up, then we can have huge impact. And that impact cascades all the way through the manufacturing system, all the way through the supply chain. So really, this is one of the huge use cases we see that could have huge impact on productivity, on waste, and sustainability. The next use case is digital twin track and trace. Many people are using the term digital twin these days, and the digital twin is really about having a connected physical and digital scenario. If you haven't got both ends of that scenario, you haven't got a digital twin, and this is what the standards are coming through. But really, what benefit is a digital twin? A digital twin is about allowing you to have insight and access to the data in the manufacturing process or in the product actually out in the wild to give you better insights. And with insights, you can develop strategies for improvement. And once you've got enough insights and you've archived them and you've structured them, you create a library of hindsight. And insight and hindsight together hopefully will allow you to have foresight, so you can start looking at prediction of what is going to happen. But it's not prediction based on hunches, it's data-driven decision making to allow you to make better informed decisions. The third use case, really about the whole factory ecosystem monitoring. As we introduce more and more novel technologies into the factory ecosystem, with the human in the loop or without the human in the loop, we're going to have a need to really increase the connected devices, the number of connected devices on that shop floor, and the ability to move them around, perhaps connecting to different nodes as they move around a facility. And a facility doesn't have to be a single shop. It could be several shops. So what we really need is the opportunity that 5G gives us in terms of reduction in latency of handover, the number of devices that can be connected, the lower latency. All of these can really impact on the infrastructure costs of manufacturing facilities. You might not have to buy as many of pieces of equipment if you've got flexibility. The real-time operational costs, because you're monitoring and you're looking at your prediction of your activity, but also optimization of the equipment utilization. And then the monitoring of these production environments. So once again, this is impacting on both the digital twin use case and the closed loop adaptive control use case. And they're really all coming together in this ecosystem that is developing the products of the future. As we extend out into the supply chain, what we really need to do is to understand the chain of custody through that supply chain. And this is really where our fourth use case comes in. You may have many different parts within the supply chain moving in and out of your facilities, might come into your facility and then out of facility again, back into the supply chain for a particular process. But really what we need is we need to understand where those components are in the supply chain, who's touched what part of the process they're in, what stage they're at, because by then we can start looking at real-time operational dynamic optimization based on that supply chain data. And that is really driving the adoption of 5G. The ability to have that data at low latency, high bandwidth if necessary, through perhaps video monitoring or the mobile capabilities, are really something that we want to demonstrate, and we want to get the rest of manufacturing really adopting it and enthused by it. The fifth use case is the use of distributed and shared hybrid reality spaces. We've all been seeing in the news recently the rise of AR and VR, you know, and this is something that can really, really impact on the manufacturing shop floor. And in fact, a bit of insight behind that was that during the last year's ventilator challenge, the use of augmented reality equipment, the Microsoft HoloLens, allowed people to make informed decisions remotely. So that expert didn't have to travel to site. That expert could have a one-to-many relationship for when the shop floor worker needed some guidance, needed some information. So we can start connecting these ecosystems of knowledge together. And what this also does it's not just about sharing knowledge, but it's reducing the cost of downtime. It's reducing the travel time. It's reducing the environmental impact of being everywhere at once and the value that hybrid reality can actually provide. So how are we doing this? Well, we're creating a network which will be initially installed at Healy House at Preston in the University of Central Lancashire, but then transferred over to the Samlesbury Aerospace Enterprise Zone, where the AMRC Northwest building is opening later this year. We've got an installation there of an IBM AC922 AI platform. But we're also linking over to BAE Systems at Samlesbury and Wharton, and then back to the AMRC in Sheffield, our Factory 2050. And it's really about demonstrating and testing and trying to understand what works and what doesn't work to drive the adoption of 5G in manufacturing. So what are the soft outcomes of this project? Really, it is about that understanding of 5G's place in next generation manufacturing. It's about allowing people to understand the blueprint for smart factory connectivity for next generation shop floors, and what are they going to look like, and to help people develop their return on investment business case for the 5G infrastructure. And then also to create the awareness and the integration strategy for the supply chain. But it's not only the supply chain of manufacturers, it's also the supply chain of equipment manufacturers, the things that are going to be connected by 5G. Working with mobile network operators and technology providers, it's understanding how to configure the 5G network and also see what works and what doesn't work for next generation manufacturing. And can we accelerate the adoption and development of the solutions to those challenges in future manufacturing? And the other soft outcomes are very much around the use of artificial intelligence. We really want to use this as a platform to demonstrate AI capabilities within manufacturing, understand where the low-hanging fruit are within manufacturing domain today, but then create that reference design and publish it and make it open to people to understand how the next generation of 5G users can actually adopt and interface with AI. There are other outcomes. We've got the technical outcomes. We're looking at connecting traditional machines, so legacy systems. How do we do that? Well, there are a number of standards out there that look at shop floor connectivity, but we've got to look at next generation shop floor connectivity. And to do this, we're actually implementing something that we've called a Factory Plus shop floor connectivity, which is looking at next generation data movement methodologies. And that's actually been published as an open protocol. We're connecting additive manufacturing machines. We're connecting robotic and automation controls. This diversity of equipment in the OT space that we're now beginning to actually connect to this is a step forward. An awful lot of these have never really been integrated in a platform that allows the volume of data that we expect to come at the speeds with underlying cybersecurity built in as a matter of course. This is where the demonstration, the test bed of 5G in manufacturing really will come alive. We're looking at how to develop, integrate, and test these machine interfaces, the protocols. How do we actually link these machines through from the shop floor into the enterprise architecture of the business and onto that orchestration platform? What does the network look like? What does radio plan look like? What works within a quite complex manufacturing environment? How do we integrate those consumer products? What about the indoor and outdoor RAN? What are the challenges around that? And what are the challenges about the core installation? Let's understand those and let's publish and communicate what our learnings are. Because the reason that we're doing 5G Factory of the Future isn't just to understand what 5G can do for us. It's also to understand what we can do for 5G. And the last technical outcome, as I referred to on the previous slide, is understanding artificial intelligence. Understanding the benefits of on-premise deployment versus hybrid cloud deployment, perhaps. How do we integrate it into the systems? And how much data do we actually need to use to develop the decision systems and decision algorithms that we hope to get? So we're really excited about the 5G Factory of the Future program, and we love talking about it. And eventually, what is it going to be? Well, it's going to be that functional test bed with dedicated work packages around those 5 use cases. We need to help people develop their own business models. We need to understand our revenue model to turn it into a sustainable test bed. And by doing that, we will understand the market analysis, we'll look at the investments, and really all of this is saying that we're not just doing this for technology's sake. This is very much about the future adoption of 5G in manufacturing. So this is where we're looking at the benefits that 5G can actually bring to us. So looking at the different use cases, so the top one, look at the EMBB slice with the hybrid reality spaces, and then the ultra reliable low latency slice for the real-time monitoring and adaptive closed loop control, and then the industrial IoT slice for the other 3 use cases as well. We want to understand what those look like. We want to understand if our architecture of each of those and the implementation of those is actually good, better, or worse than the other demonstrators that are being stood up. And this is where UK 5G really plays a critical role, bringing together all the actors in this ecosystem, all the people that are testing the systems, testing the architectures, and working out whose is best and why is it best, so that we don't have to reinvent the wheel, and so that it really drives the UK as an expert adopter of 5G in manufacturing. We've got some targets that we hope to hit. These are our target outcomes and impacts. So with real-time monitoring, can we look at a 15 to 25% reduction in the number of defects, the amount of waste, and the machine downtime? Predictive maintenance should come into that. And by using predictive maintenance, we can optimize the use of equipment, thus impacting on the productivity challenge. Digital twins. We're looking to achieve a 15 to 20% machine utilization improvement. So a reduction in idle time, improved scheduling, improved utilization of that equipment. Because if you've got equipment that's not being used, then it's a cost. So can we actually drive through the acquisition and use of data, this real dynamic scheduling and the improvement in optimization and productivity for the shop floor. Using FEM, can we look at 5 to 10% improved machine utilization, reduction in energy utilization? You know, there's a number of strategies that are beginning to emerge around the factory ecosystem to really drive down the energy costs within that facility. And we think that 5G, through the use of the platform to move the data around, will really allow us to drive that improvement. As we look out into the chain of custody and into the supply chain, we're looking for a 30% reduction in lost and damaged assets, and linking into the one above, improved schedule accuracy and providing that transparency across the supply chain, something that is really, really needed these days, has been shown in last year's pandemic and the response across the supply chain. And finally, the hybrid reality spaces, we're looking at reduction in travel costs, maintenance time, but also a reduction in the environmental emissions that travel would otherwise have impacted on. So apart from that reduction in travel costs, maintenance time, it's about remote support, it's about collaboration and training and maintenance. So a number of different impacts and outcomes that we're aiming for there. For the region, for the Northwest up in Lancashire, we really want to engage with those SMEs in that region to be able to show them the benefits of adopting this sort of technology and to attract inward investment in the end user product manufacturers as well. So where have we got so far today? Well, we've got an integrated network and compute functions for the ultra low latency activity. We've got a 5G standalone installation provided by Nokia. We've got our IBM AC922 compute on premise, and we're already beginning to get some insights from that linked to our own high performance computer on the shop floor as well. We're also extending into that other area that we talked about, and that is the end user products. So we're beginning to investigate the potential for native 5G device manufacture and creation, and just seeing what the 5G as a platform can really provide for manufacturers in terms of the reduction in the latency between data being acquired and insight being derived, and then that insight being actioned on. So that's really been a very quick introduction to the 5G Factory of the Future program that's being delivered out of the AMRC Northwest with our partners IBM, BAE Systems, Miralis, MTT, Digital Catapult, and our mobile network provider AQL. Thank you.